groups. Okay, there are too much groups in a different system, but now I talk about group theory. Okay, we took for example, for a group, it must have some elements. Any groups have must have some elements. Okay, we take G's group have two elements, for example x and y. Group have two elements, x and y. Okay, so now I want to study this group. Okay, so when I want to study for any group, we must to study element or a composition of element or composition a composition for element. A composition. What's a composition, or what's mean a composition? What, a composition? It's an operation for mathematics. Some like positive or negative or multiplication or so whatever anything. Okay. Okay, I take example for show what's the composition. When I have a group, it's have element, for example 0, 1, 2. I want to make a composition for this group. Okay, it's mean a composition, and this group have, for example, a multiplication. Okay, this is symbol for composition. And you have 0, 1, 2, 0, 1, 2. This is 0 composition 0, 0 composition 0. A composition is multiplication. 0 composition 0, 0. 0 composition 1, 1. And 0 composition 2, 2. Okay. Now we start for this. 1 composition 0, 0. 1 composition 1, 1. 1 composition 2, 2. Sorry, 0 composition 1, 0. Sorry, and 0 composition 2, 0. And 1 is identity. 1 is its identity. 1 composition 0, 0. 1 composition 1, 1. 1 composition 2, 2. 2 composition 0, 0. 2 composition 1, 2. And 2 composition 2 is 4. It's multiplication. It's operation of mathematics. Okay, now I see 0, 1, 2. 0, 1, 2. Okay, this is I mean this is it's mean for a composition. Now about group theory. What's mean for a composition for a group theory? We take for example group of two elements, x and y. Now we need to study this group. Okay, when we need to study any group, we need to study elements for this group or a composition for element in this group. All x and y for is element in group G. Okay, Okay, now we make a table for this group or structure for this group. This is composition. You don't forget composition. Check this symbol. Okay. Okay, this is group. Have two elements, x and y. X and y. This is composition. Here, x composition x, and here x composition y. Here y composition x, then y composition y, y composition y. Okay, now what is the properties of this structure of this table? What's the properties? We study this. Number one, closure. Closure, yes. Any table in the group 3 must be closure. This is here and here and here and here. This is closure. It's clear. It's clear for closure. Number two, associativity. Associativity. Yes, this is, we must take this associativity is very difficult, because how to compose of any two elements like x and y, how to compose, or and what's it mean, or how to compose for three elements. Okay, now we take x and y. Okay, x compose y, or compose y. Two elements or three elements. It's equal x compose y together, compose y, and x compose y together. The result, it's equal. That is associative. Okay, to clear this this mean, we take a group. It have two elements, x and y. Okay, now what is a set permutation for two elements, x and y? We have two sets, x, y. This is the first set, x to x and y to y. This is the first set. And the second, x, y, x, y, x to y, and y go to 6. We have two sets. Okay, when in this set, x go to 6 and y go to y, this is no different. This is no different. This is identity. Identity. Okay, we give I symbol. But in another set, x transition for y and y trans for x, we take symbol t. Okay, that's clear. Now we want to make a composition for these two elements. We need to make a composition, the symbol for composition. We have two elements, I and T. I and T. I and T. This is I composition I. Here I composition T. The first is I, and here T composition of I, and here T composition of T. Okay, number one, take I composition for I composition for I. Okay, X, Y, is I for identity. X and Y to X and Y. This is no different. X and Y. It's identity. I. Okay. I composition of I. The answer is I. Identity. Okay. 2. I composition T. 2. 2. I composition for 2. Sorry. 2. Number 2. I composition for T. I composition for T. I composition for T. Its identity. A or X, Y, X, Y. Composition for T. X, Y. The answer is T. The answer is T. This is identity. Identity. X, go to X and Y go to Y. Composition for T, this is transfer. X go to Y and Y go to X. The answer equal T. I composition for T. T. Okay. T composition for I. Number 3. T composition for I. Okay, no problem. I want to write here T composition for I, but I want to write I first. This is T composition for I, and T composition for I. X, Y to X, Y. This is identity. Composition for T to X, Y. T. T composition for I. T. Okay. Now T composition for T. It's number 4. T composition for T. T, X, Y, X, Y. This is T. Composition for T. X, Y. Now this is X. And this is X. This is Y. This is Y. This is identity. Yes, it's clear. I. Okay, now we want to study the associative for these elements. The group have two elements. Sorry, X and Y, or maybe A and B, whatever. G group have two elements, A and B. We remember the composition of A and B. First set A and P, that is the symbol is I, identity, and the set, another set A, P, trans, T. Okay. So now we want to study the associative for three elements with A, P, P. Okay. I composition, T composition, T. Okay, what's the answer? What's the answer of this operation? I composition, T composition, T. Okay, I identity, I composition, T composition, T, and we want to compare between this answer and I composition T and the answer together the separation composition T, and compare another I composition, the product of together composition T and T composition. Okay, what's answer? I, AP, composition T, I go to I and P go to P, this is identity. Okay, composition T, A go to P and P go to A. Composition T, A go to B and B, A. I, this is A, this is result, final result A, B, A, B, this is identity I. Okay, I composition T, it's I composition T, trans A, B, this T, this T, result is T, T composition T, another result P, P, trans A is identity T minus 1. We make two rotation. Okay, it's identity. And I, this is I identity. Composition T composition T, I composition I. Now we can talk I composition T equal I composition T together composition T equal I composition together T composition T. This is as associativity. This is associativity. Yes, it's associative law. Associativity law.